One of the approaches is that we have been mapping this whole building site with sensors. So we are monitoring noise, emissions, and also wind speed, wind direction. And that is to make sure that we understand exactly which emissions are coming from this building site, what is the level, are we below or exceeding the limits. We also have sensors outside the building site, and that is to understand the background emissions. We do have this sensor network. It was set up actually before the building the activity was started here. That means the demolishing phase. We set up the sensor network before that, so we have live high-frequency data from that time a year ago until now and continuing.
At the moment we are just digging and to the foundation for the whole building, and we want to try to put some measurement down into the side to measure what the impact is for the people, NOx and particles. So we can be sure that we have the right working condition for our employee, and we also can document it if there will be some issues about it. At the moment we are only about 4 meters down, but when we are finished there will be some drilling. We will drill holes 70 meter down and 1.8 meters in diameters, 70 meters down, and to be the foundation for this whole building.
It's been used for corn products way back, and then it's been used for different other sub-industrial purposes since then. It was more or less a building you would suppose should be kind of demolished. Also, we do have to support the work with this grid. We have a tower camera. Actually, we will soon have 2. That means each quarter of an hour we can actually see what is going on the building site. So if we see some kind of exceeding emissions, we can take a look whether it seems like there's a lot of activity on the building site. So we also have sensors that are covering the background emissions. So we do have a very good coverage. And actually this sensor network, it is supplied from a Danish SMV. And the data, they are now also being introduced into the Aarhus Smart Site digital platform. So we are not just testing the system, we are also working together with Aarhus to integrate it into their platform. So we are doing many other experiments here. One of them is to do some trials and tests with electrified machinery. The first test we did was unique. It was the first time in Denmark where we had a 23, that means above 10 tons machine, an escalator from Volvo. There are a few prototypes around, but not to be misunderstood is that these machines are coming in few years. So to have one here was unique. We brought from DTI our 300 kilowatt fast charger because the machine from Volvo was delivered for testing with a normal overnight slow charger. And the reason for that is that we wanted to test a normal typical scenario. And without the fast charge, the machine would not be capable of operating enough time. So we had this set up with the Volvo electric 23 tons escalator and the DTI 300 kilowatt charger. The escalator was limited to charge up to 150 kilowatt. So we have put that into a lot of different type of works, duty cycles. And the general impression was kind of better than expected. It fully fulfills the requirements when it comes to replacing a diesel-driven similar construction machine. when it comes to the way to operate it, which also links into safety, but also the performance of the machine. There was no problems with the charging. We had overnight slow charging and during the breaks fast charging. Only when we had very high demanding activity like loading trucks on the go, that means you have like 5 trucks, there's always a truck here that is loaded with concrete or whatever it is. Then we saw that there was a lack of range, or what we should call it. We would to fulfill the requirements there, we would need to see a combination of bigger battery, a higher fast charge power, but also there's a need to address that the brakes has to be fit in a way that you optimize the use of the machine. So that was the machine part. Now the infrastructure part, from this DTI fast charger, it was connected to the ND Flex Lab, which is a DTI facility where we also have a data platform. So we could follow the charging patterns, and we can use that later in the project to simulate the need for power and energy. If you have, if you would imagine that we would have a machine with a higher power charge, or maybe more machines, because in the situation we have here, where we are building a sky-high building of close to 150 meters, is that still the power that is supplied to this building site would only cope with a couple of machines. More than that, you would blow the fuse. So very important for us is to understand, and we're going to do some simulations when we're going to work with the data analytics. We will look into scenarios of how can we make sure in the most feasible and low-cost way that we have power enough. That could be a matter of how you plan the working day. I think it will also lead into the use of energy storage. That means batteries, container-sized batteries. And you would maybe even though need more power to the building sites, which is very expensive. So we are going to look into that as well. Also unique for this building site is that we are cutting emissions here a lot with the use of biodiesel. Biodiesel is of different nature. So the biodiesel that is used here has certificates that prove around 90% cut of CO2. So that's obviously is helping the climate a lot. What we are doing here is that we are testing with very accurate portable emission testing equipment. What is the consequences on the environment? Because we know the climate part, but is it one-to-one when it comes to particles, small and big particles, NOx, etc.? That we will document because in this case, Aarhus as a constructor, they are using a lot of money for this due to this additional cost of the biodiesel. And they need to know exactly what do they get, both from the CO2 part, that's the certificate, but also from the other emissions. And also we obviously look into the energy efficiency, that part. What we also do here, that we are also monitoring the power grid at the building site. That means the main power switchboard and all the subboards. So we know exactly how the energy consumption is. We also monitor if the load on different phases is equal, because often we see that that's not the case. And then you can have problems with blown fuses, which are not needed. So there you also look into a more digitalized setup in the future, where companies like Aarhus, they will have monitoring showing if something is to be changed before you have a blackout. So that's also a part of what we're doing here. Why did we start this project? Well, basically, if we go back 5, 7, 8 years, there was a lot of meetings and discussions in Scandinavia on how to electrify the construction business and the work on the building side. And at the same time, what we saw was that the availability of machinery was the small machines, very few tons and lower. So if you look at where the diesel is consumed, well, the majority of the diesel is consumed by larger machines. So what we believe was needed was a product that was more realistic, looking into a lot of different means on how to reduce emissions, including electrification, but also a lot of other means. So that's the reason why we set up this lighthouse project. In general, at DTI, we do a lot with gathering the value chain of stakeholders in different sectors, because this way of learning to operate and be innovative together is important for speeding up the green transition. So when we talk about project results, well, this project is running over 3.5 years, and we are ending up in the mid of 24. And by that time, what will be seen from this project is some facts, some guidelines. But what do we have the very high focus on is to supply solutions and tools that can be used directly after the project. So not just a report. So we are doing a lot on communication and dissemination. We are happy with the high kind of interest we see for this project, and obviously also for the visit here from Iceland.